Okay, so what's going to happen now is we're going to end up getting data, right, or have values for two quantitative variables. And we then want to use technology to find the least squares regression equation or line, which we're talking about the line of best fit you may have heard. Again, there are some instructions here, but I'm going to show you how to do that. Just be mindful, again, different calculators give you different outputs. This is a sample output from StatCrunch. It can look overwhelming, but if you look carefully, you'll see what the variables are, right? The correlation coefficient, the R value. You get the line of best fit equation here. You also get the intercept and slope in here. You will see it down here in the parameters. So let's go ahead and take a look at how we actually do that. And so just a simple example of scuba divers, right, have a maximum dive time they cannot exceed when going to different depths, right? There's a lot of pressure in the water, and so there's a relationship, right? And so the deeper you go, it looks like you have less dive time. You can't stay down as long. And so it looks like, and again, what relationship that would be, as the X values are increasing, you go deeper, the Y values, the max dive time seems to be decreasing. So what ends up happening is you're going to type that data in a StatCrunch, and we're looking for output that's going to look like this here. So I want to show you how to get this type of output here. But again, you'll look carefully, you'll see you get an equation, you get a correlation, you get your intercept and slope, right? It does all this. And remember, in algebra, you used to do this by hand with 2 points. Now we have so many points here, we need a more advanced technique to kind of help find those values, right? Not just picking 2 by hand and leaving it to subjectivity, but to actually come up with a method, right? And so here is, after you put your data in, depth and max dive time, sorry about that, there you go. What you're going to do is stat and then regression, simple linear, because we're studying linear relationships. Things get more advanced with polynomials, polynomial relation, meaning that it's going to be curved situation, or multiple linear regression with situations where you have more than 2 variables. But right now, simple linear, choose your X variable, depth, Y value, max time. That's it. That's all it takes. And then you compute. And that's where you got that. That's where you get this output right here. And so you can see your max dive. You can see your equation here and your parameters here, right? Because these are the estimates for the population. We had statistics, we had sets of values, calculated an R value. You see how it's negative here? This negative indicates that we do have a negative relationship. And then when you run a regression, a negative association, you can then see, notice down here, you get the graph. Other calculators may show it all at once. StatCrunch, you have to look for both of them here. And so you'll see it's starting to decrease. As depth increases, it decreases. Now we can make a prediction. So that's what we want to be able to do. Again, here is your, you want to pause to just study that, and then go back to, go back over here, and then we can go ahead, right, use the least squares regression line and predict the max dive type for 110. So go ahead and pause so you can see we have the parameters. Here's your equation. I'm looking for the y hat, the predicted value. Notice StatCrunch likes to write in, instead of x and y, they use the variable name. So you got to remember what your x and y are. And so you have your equation, you substitute it in, use your calculator, right? You're substituting the x value into x, and you get 4.67 minutes for 110 feet. That would be our predicted. And then we end, right after you have a predicted, we want to know how well what's called the residual. The residual tells us how far the observed value is from the predicted. We want to know, our prediction's good, right? And so we're making predictions about some observed values, or even that helps us determine how well our equation fits, so that maybe we can use this prediction for a little bit in the future, or for values, so that we can come up with predictions for other values that we haven't observed yet, right? And so the residual tells us how far, right, an observed value is from a predicted value. Remember, you have an observed value, you have the predicted value, and then you subtract the two. And so what would the residual be for a depth of 60 feet? Well, in order to do that, you have to first find the predicted time. And so you can see for 60 feet, we're looking for the time. You substitute it in, you get 60.38 minutes. I rounded. What was the observed time for 60 and 55? It's right here. And so then we know that's the observed time, and then you calculate the residual using the y values. Remember, it's the predicted y value and the observed y value, okay? For that residual equals observed minus predicted, and you end up with negative 5.38. The last piece that's essential to least squares regression is the slope and y-intercept, not just the numbers, but their meaning. And so you can see that here. So when you get those two numbers, right, the slope in our case for each, and this is a constant, for each additional 1 x unit, so for each additional 1 foot in depth here, okay, so every time you increase the depth by 1 foot, we predict a 1.114 minute decrease, right, because it was negative max dive time. And so there's this relationship between, we'll practice this more with some more examples, but think about this relationship. Remember, change in y over change in x was our slope way back in algebra, y2 minus y1. And then the interpretation of the intercept, we predict a max dive time, 127, when the depth is 0, because remember, the y-intercept occurs when x equals 0, which means that depth is 0. This may not make sense in this case because depth of 0 means you're at the water, like above water. So this one doesn't not make sense. And then here's the sentences you would use to describe them. What we just did here, I just put it into some sentences with this problem. That's it.